All right, so we're gonna figure out what the critical numbers are for these functions and figure out where it's increasing, decreasing, and if there are any relative extrema. So maximum or minimum, so largest values, smallest values. So we're gonna go over 31 first. So in 31, we got f of x is equal to x plus 4 over x squared. So what we're gonna do first is find the first derivative. So let's find f prime of x. So we're going to use the quotient rule. So the derivative of the top, which will just be 1, times the bottom, minus the top function, multiplied by the derivative of the bottom function, 2x, all over the bottom function squared, all over x squared squared. And so let's simplify this. So we'll get x squared minus 2x squared plus 8x all over x to the fourth. Simplifying, we get negative x squared minus 8x over x to the fourth. And you can cancel an x term from each term by, we can just look at it as dividing each term by x. And so you just get negative x minus 8 over x cubed. Okay, so now we look for where the function and derivative function. So where's f prime and f of x undefined? So f of x is undefined when x squared equals 0. So remember, the denominator equals 0, so x squared equals 0. That means, it's undefined when x equals 0. So there's going to be a point of discontinuity there. So let's write f of x is undefined for x equals 0. We're going to touch back on this at the end. So that's something to keep in mind. F prime of x will also be undefined for x equals 0. So we don't have to mention it twice because x cubed equaling 0 is, going to give you 0. And now we find where f prime of x is equal to 0. So we're going to set this expression equal to 0. So 0 is equal to negative x minus 8 over x cubed. And then we solve this. Let's solve this by multiplying both sides by x cubed. So that now would just be 0 times x cubed, or just 0 would just be equal to negative x minus 8. Add x, we get x equals negative 8. And then so this will be a critical number as well. So we have critical values here. We have two critical values. X equals negative 8 and then x equals 0. So what we do is we're going to break an interval up at those points. So I like to set up a table where the top row is broken up at these points. So we go from negative infinity to negative 8, and from negative 8, that's not negative 8. Negative 8 to 0, and from 0 to infinity. And I'm going to pick a test point. Test a value of x in each of these intervals. So I can just pick any number for x in here. I'll pick x equals negative 10. Here I can pick x equals negative 1. Here I'll just pick x equals 1. So it doesn't matter what number I pick, just as long as it's in the interval. It's in the interval. So then I want to see what the sign of f prime of x is in each interval. all I need is a sign. So I'm going to evaluate f prime of -10, f prime of -1, and f prime of 1. Let's see what I get. So I'm going to plug -10 into this equation. I'm going to get -10, I'm going to positive 10 minus 8 or -10 cubed. That'll be -1000. So that'll be 2 over -1000. Now I don't even need to calculate the value exactly. I just need to know that's negative. So I'm going to put that as negative here, because that's a negative number. Now, next I'm going to look at what f prime of 1, what f prime of -1 is. So plug -1 into here. So negative, so I'll get 1 minus 8 over -1 cubed, which should just be -1. I'll get -7 over -1. And negative over negative make a positive. Again, I don't even need to find the exact value. It's good if you do, but sometimes it can be tedious. All I need to know is that this is a positive number. So I'm just going to write that's a positive number. And now I just find f prime of 1. Plug 1 again into here. So -1 minus 8 over 1 cubed, which is this one. So that'll be -9 over 1. So this will be a negative number. So then I'm going to put negative in here. And now I can describe what my graph of my function is doing. So when the derivative is negative, the graph is decreasing. The function is going downwards, decreasing. When the derivative is positive, the graph is increasing. So it's going upward. And when it's negative again, it's going to be decreasing. So now I just summarize what this is doing. So I just kind of write it in words, depending on how your teacher, professor wants it. I can just write f of x is increasing on -8 to 0 and decreasing on -infinity to -8 and then 0 to infinity. Now, in addition to that, we know that it's going to be discontinuous here. Because remember, we looked at the original function, it's undefined for x equals 0. So it's discontinuous at x equals 0. So let's write that as the second point. Is discontinuous at x equals 0. Now it's discontinuous here. That's where 0 is. But it's not discontinuous here. So if it's going down, then going up, that means there's going to be a minimum point here. So that's going to lie at the bottom, downward to upward. So there's going to be a relative minimum at -8 f of -8. -f of 8. Now I can evaluate f of -8. I want to be exact. So I just plug -8 into here. I'm going to -4 over 64. So this is the same as -8 over -8 common -1/16. Same idea, as long as you get the mean. big picture. And there you go. That's all you gotta do.